Lovely. So, hi guys, I hope you understand English. We all okay? Because I can't do it in a different language. So, hi, thank you for the team for inviting me here, Staticus. I've been to Vilnius a number of times, so I'm growing quite warm to the city, even though it's a bit colder this time of year. So, I'm John Elliott from Guardian Glass. Here to present to you today our sustainability, or as we call it, our environmental stewardship. So we like to steward people through our sustainable traits. So what we're doing in the glass production, which is generally a very, very energy intensive production, and how we are looking to lower embodied carbon in our production. So I've been with Guardian about 7 years now, and I've seen quite a bit of change in that time. I look after the UK and more recently North East Europe, hence why you've got me today. So before I get into the actual presentation itself, just a little bit of a background in Guardian Glass. So we're owned by Koch Industries. So Koch Industries is a privately owned American company, a big global animal of a company. With a very distinctive culture. And part of that culture is within Koch businesses, Koch reinvests 90% of all its earnings back into its companies. So if you look at the second bit of information down there, so more than $168 billion has gone back into Koch companies for growth and improvement since 2003. So that's only 20 years. Koch's annual revenue is around about $125 billion, so it's a very stable company. At Koch, we have more than 120,000 employees worldwide, and we work in more than 70 countries. And on the right-hand side, you can see the umbrella of Koch companies. You can see Invista, Molex, some big names there, and of course, Guardian Glass. So Guardian Glass, who are we? So we're glass manufacturers. Are you guys architects? There's some architects here, some consultants. So you specified glass before, so you understand a bit about glass. So Guardian, we make glass. So we make big sheets of glass that we coat in performance coatings for solar control and lumicity, and we supply these to the glass industry. We have 22 float plants globally. Our headquarters are in Auburn Hills, Michigan, USA, and Guardian has more than 7,000 employees worldwide. And we work across 5 continents, so we have a very much a global footprint. And to give you an idea of the scale of glass production, if all our glass plants are producing daily, which they are, we're producing approximately 500 kilometers of glass every day. That's 365 days a year. So we provide a lot of glass into the world. We have a lot of patents, and we have 700 different glass products. And when we say that, these aren't all for buildings. We provide glass to the car industry. We provide specialist glass for museum casings, etc. So in our portfolio, we've put glass on the Mona Lisa. So there's a virtually invisible glass on the Mona Lisa, and we put glass on the Burj Khalifa. So the most important painting in the world to the largest building in the world. So it's quite a mix and portfolio. In terms of Guardian Glass Europe, who I work for, we have 6 float lines in Europe. So we have 1 in the UK, we have 1 in Germany, we have 2 in Poland, and 2 in Luxembourg, and 1 in Spain. We've got 7 distribution centres, and Guardian Europe has 2,300 employees. So we're a large share of the Guardian portfolio, and we've been in Europe for more than 40 years. So we've got a very strong footprint, and our glass plants are very strategically placed in terms of across Europe to minimise embodied carbon and transport costs. So, bit quirky this one here, to go into the actual products and how we're reducing carbon. So, Nexa 6 and Nexa 9, has anyone heard of them at all? No? Good. That's okay. That's really good, because that means hopefully you'll come away with something today. So, Nexa 6 and Nexa 9. They're not space stations, they're not new planets, nothing of the sort. What they are, in fact, is, and we're stuck, sorry guys. They are in fact our 2 new glass options from our range of lower carbon glass products. They're the result of many different initiatives across the fields of technical innovation, research and development, and plant efficiencies. The word Nexa was derived from the Latin word for nexus, which is a meeting point for two entities. Marketing have called it that, and I think what we like to say is that we brought together Guardian, Nexa and innovation and converged that into one. Why do we call it Nexa 6 and 9? As I said, you've not missed 1 to 5 or 7 and 8. It's called 6 and 9 as this is the values of their embodied carbon. So Nexa 6 has an embodied carbon value of 6.8 kilograms of CO2 per square metre based on formula glass, and Nexa 9 has 8.58, so it was nearly Nexa 8. And the idea is that we grow the product range and make further cuts in that respect. Just bear with me. So in terms of questions, I don't really think, unless you've got some you can ask for a small audience, but I imagine you're probably asking why two products, where do you make them, how are they made, what's the lead time, can you specify them, etc. Well, answering your questions. Two products, it's just the start of our range of low carbon glasses, but it is a continuation of our journey, looking to the future, to put low carbon glass on the future landscapes. So through plant efficiency, and where needed, we increase the cullet. So those who don't know what cullet is, when you make glass, a batch of glass is predominantly sand. Then you add other elements such as dolomite, soda ash. They strengthen the compounds, and you add cullet, which is recycled glass. And what cullet does, it reduces the melting point in the furnace. So that reduces the embodied carbon. But there's only a finite amount of cullet you can include in a glass production without compromising your aesthetics and your performance on the outside. So the Nexa 6 product, for example, to get that embodied carbon figure down to 6.38, we have to increase the cullet ratio from around about 30% up to 60%. The Nexa 9 is slightly different. It's not as a lower embodied carbon figure, but we achieved that purely through the plant's efficiencies. So that doesn't have any increased cullet. So the idea is that we have two products that are differently placed for different requirements, but equally they are different prices as well. So they are done to align with project budgets and project requirements. But both of them have no compromise on aesthetics or performance over our standard glass. And in fact, even our standard glass is a lower carbon glass compared to the EU average. So in theory, we have lower carbon glass throughout the options. And it's designed for buildings, new buildings, or equally retrofit buildings, adaptive buildings and refurbs. So how do we do it? Well, it's through innovation, R&D, investment, and again, our manufacturing expertise, our history. Through these elements, we've reduced the levels of embodied carbon against our standard glass, as I've mentioned. Production methods at our glass facilities are advanced. We have a very advanced, what we call our fleet of assets, which is our plants. And this obviously leads to greater efficiency. Nexa 6, as I said, increases the cullet ratio. The more cullet you use, each tonne of cullet is equivalent to 1.2 tonnes of raw material, so it drives down the CO2 emissions. Where are they produced? The other good thing is that we don't produce them in one plant, so we're not moving cullet around Europe. We are producing the Nexa range across 4 plants, and here's 3 of them here. So we produce them in the United Kingdom, in Germany, in Poland, and now in Luxembourg as well. So for our direct customers, so we make big sheets of glass, we laminate them as well, we coat them, and then we send them off to our direct customers who are the unit makers, so the guys that put together the IGUs, and predominantly they're based around these regions. So we have a really good coverage for monitoring transportation movements. Can you specify them? Yeah, absolutely. They've been around now for about 6 months. So we have MBS documentation. We equally have environmental product declarations, which are EPDs for all the products. And we have a team of experts in the technical department which can work out different compositions for you, and that will give you the embodied carbon numbers for those compositions. So that's whether they're monolithic IGUs or whether they've got, laminated elements, but they can provide all that for you guys. When are they available? That's a simple one to answer. As I said, they are available. They are available right now. And in fact, we've got our first major project in London which is around about 9,000 square meters of low carbon glass. It's a Nexus 6. The investor wanted a very low carbon building. So not only is our glass low carbon, it's a laminated outer pane, laminated inner pane, and even the interlayer, the PVB interlayer for the laminates is a low carbon interlayer. And then the aluminium framing around the system is a Technal Hydro Circal low carbon aluminium. So we are partnering with the aluminium guys to give as much low carbon as possible. And London in particular has got a very, very strong push on reducing carbon. But it's not just the end product that we look at in reducing carbon. It's not just the glass that comes out the factories. It's the factories themselves. So a glass plant generally lasts about 15 to 20 years. So you build a glass plant, which is basically a big oven, a furnace. You light the furnace, and it lasts about 15, 20 years before you need to go in, turn it off, let it cool down, and then effectively rebuild it. Now, 20 years, 2 decades is quite a long time in any technology. If you think about your mobile phones, you've all got smartphones. 20 years ago, you probably had something that was very, very different to a smartphone. And although glass isn't on that technical trajectory, we still have technical advancements. So we every time we change a plant, we look to increase its productivity. We look to increase its sustainable credentials. So, for example, we've done several plant repairs recently, and you can see from the figure there, we've reduced carbon emissions by around about 16% since 2019. And that comes down to the first slide where I said that Coke as a business reinvests. During COVID, when nobody was investing, Coke invested 120 million euros into our UK plant to make that more efficient. So that is producing more glass at less energy. It's also got a heat recovery system underneath it, which we've not needed to turn on because the plant's so efficient. Since then, there's been other terrible things in the world. Obviously, we've had the war in Russia, we've had COVID, we've had other stuff like that as well. We've invested heavily in Germany, and most recently, we've invested very heavily in Luxembourg. So we do have, as I say, a fleet of assets which are the most up-to-date and efficient plants in the industry. Within the plants, we're harnessing technologies as well. And one of the most important ones we've done is we're now supporting our plants with oxygen-fired furnaces. So traditionally, air is used in the furnace for the combustion process, so that's how we light the furnaces. We're replacing that with oxy-fuel, so pure oxygen, and that has given us results with approximately 25% less natural gas being used, 15% less CO2 emissions, a decrease in the generation of nitrogen oxides. And if you look at the carbon intensity improvement, it's minus 33% when you compare that with less energy efficient plants. So the investment it's like a holistic story, I suppose I'm trying to tell you guys. It's not just a product that we provide, it's the holistic approach around it. And it's not just carbon we look at, it's all gases. So we install emission control systems on all our plants, and this has helped to reduce nitrous oxides by 65% over the past years. And then we come on to the subject of recycling, which again is becoming very, very, very key. So we touched on cullet earlier and its impact in reducing melting temperatures. Therefore, I think I mentioned, you'd probably be thinking, well, why not just put in 80% cullet, 90, 100% cullet, which sounds great. It'd be really carbon efficient, but what you'd get as a product is something different. It would cause problems. So there is a tipping point, which we see at the moment is that 60% mark. But we have increased cullet in general in our standard production as well. So when I joined Guardian, we were using probably 18% cullet, maybe 20 at max 7 years ago. We're now standard using 30. So again, technology has enabled us to increase the cullet ratios and not compromise on what comes out the other end. But in terms of taking glass off buildings, this is still an issue in our industry. So currently, very little glass comes off buildings and comes back to glass manufacturers. A couple of reasons, really. There's no regulation for starter in the UK, so no one has to take glass and recycle it. It's still very simple and easy to go to landfill. I think this is going to change at some point, which is great because it needs to, because currently it's less than 2% of all glass that's coming off buildings is going back to glass manufacturers. which is obviously a concern. So where do we get cullet from? Well, we use our own offcuts. We get from our customers, we buy cullet, and we take glass off buildings. So we're starting to move with the glass off buildings. And what we've got at Guardian is a value proposition where we partner with recycling companies up and down the country in Europe. And the idea is that an architect has a project where they're taking a building down and they want to recycle the glass. They'll call us in, we will go in with the recycling partner, we will assess the building in terms of the glass, what composition it is it coated, is it heat treated, so toughened, can it be taken out and put back into a glass furnace, or if not, can it go downstream, can it go to bottles, furniture, insulation, road aggregates, etc. But the idea is to maximise and recycle as much as possible. Now, in terms of what can come back to a glass furnace, it has to be grade A quality glass. But we can recycle any monolithic glass that has got a coating, any monolithic glass that is toughened with a coating. We can recycle single laminates that are coated and toughened. We can recycle IGUs, it's a bit more complex, a double glazed unit. We can recycle tinted glass. We struggle with things like ceramic frits, so anything with solid colours, so that will go downstream. But we are moving quite heavily into the recycle market, and we're looking for recycling jobs all the time because we're looking to raise that 2% figure up and get more glass from buildings onto back into glass production, circular economy, back onto buildings. And it's not just, again, it's a holistic approach. It's not just glass that we recycle. We laminate ourselves. So laminating, if anyone's not aware, is just two bits of glass with a PVB, a polyvinyl butyl interlayer bonded together. When we buy the PVB in, it comes oversized. That's to allow shrinkage and trimming. So when we trim these PVB pieces, we now send them back to our PVB supplier, who then puts them back into their system, so they close loop, they recycle. And it might not sound much, just PVB trims, but if you look at the numbers, across our plants in Europe, we've recycled 72 tonnes of PVB per plant per year. And over the last sort of 5-6 years, well over 3,000 tonnes of PVB. So we are really driving this holistic approach. It's not just about the glass itself, it's about everything around it. On that note, it's not a slide here, but we heavily recycle water. So we use a lot of water in our glass production to clean the glass before laminating, before coating. And that wastewater now is on a loop, so it goes back in again. Vehicles as well, we lead the way in trying to design our stillages on our lorries to hold as much glass as possible, and we're currently holding about 26 tonnes of glass per vehicle, so we've been able to actually remove vehicles from the road, so to reduce that embodied carbon footprint. So I mentioned that we recycle our own glass, so all our own trimmings, but our factories are very lean. We're very waste averse, so there's little that gets rejected, but what's rejected goes back into the furnace. The trimmings that we cut for the glass goes back to the furnace, but equally we collect from our supply chain as well. So where we deliver glass in our lorries to our partners, instead of coming back with empty lorries, we come back with their cuts as well. So we do try and get as much glass back from our supply chain as possible. And then lastly, and it is lastly, guys, the future. What does the future hold for glass? We've touched on what we're doing currently with the glass products, but it's looking ahead. We can't stand still. Things are moving very fast. So we are a member of Glass Futures. So Glass Futures is a non-for-profit business. It's a pilot plant that we've set up in the north of England with one of our competitors and a whole bunch of other industry companies. And it's like a centre of excellence. It's where we're looking to drive the future for glass technologies. So in this glass plant, we're trialling new fuels, new energy. So we're trialling things like hydrogen, electric, to see if we can further reduce gas usage, basically. We're also looking at other developments such as robotic operations. We're looking at heat recovery. We're looking at secondary raw materials. We're looking at ways of getting more cullet. We're looking at new different compositions and treatments and new coatings. So it's our future. It's the next generation. It's the first time that the glass industry actually has somewhere where it can trial and test for the future, because it is generally, as I mentioned at the start, an energy-intensive business. And then really, go back to trying not to hypnotise you, but go back to Next 6 and Next 9. These are the products we're using at the moment, the low carbon. We probably will be introducing a further Nexa in the coming years as well. And that's where we are as Guardian. I hope you understood that, guys, and it was of some use to you guys going forward. Thank you very much. Thank you. Thanks.